We're going to keep looking at polynomials today. Yesterday we kind of looked at properties of exponents. Polynomials are expressions that have exponents in the terms. This first problem on your sheet says Shelley has narrowed her choice for which college to attend. She is most interested in Southwest Minnesota State University, where the current tuition is $3,872. Shelley assumes that tuition will increase at a rate of 6% each year. Express the tuition after X years as a polynomial. There's our word polynomial. Polynomial means there will be some kind of degree on one of the variables. So on this one, her tuition, she's for sure going to pay the price to start with here, $3,872. The next year, it would increase by 6%. So she would pay that $3,872 times 6%, and that would be added on. So every year that rate gets added on to the next year's cost. So this one will be her initial one times or plus the rate, and we always do percentages as a decimal, so it'd be 0.06 times 3872. So it's going to get multiplied on. So that would be her tuition for the next year. So if you added that together, and for the following year, you would add this values together, figure out what it is, and then you keep adding it. After a while, her tuition would then become $3,872. Every year, we're going to be adding this 0.06, so it becomes 1.06 rate added to 100%. And then it would be to the x years. This is example polynomial. You can see you got a variable here, so this becomes a polynomial function. All right. One thing we're going to be looking at is the degree of a polynomial. The degree is the largest exponent or sum of the exponents of a monomial term in a polynomial. Monomial, this word monomial means one of the, it's like one term within a polynomial. Polynomial can have many terms. So you're looking at what's the biggest exponent or sum of exponents in any one term within the polynomial. Let's look at a couple examples on your sheet. On A, we only have, it is only a single monomial. There is only one exponent, so the degree would be the exponent, 5. 5 is the biggest power or exponent we see. All right, B, this one is a polynomial. We have 3 monomial terms within the polynomial. What is the biggest exponent we see? On this first one right here, we see a power of 3, so the degree would be 3. On the last term, there's 2 terms, first one, second one. On this one, our value or exponent on the second term is a single 1. If you don't see a power, it's always 1. On the second one, though, we have 2 different variables, x and y. So what we do is you add or sum their exponents. So this one would be degree 7 plus 4, which is 11. So this would be degree 11 for C. So the degree is the biggest exponent you see. All right. On these next ones, we're going to try and identify again what is the degree. So on the first one, looking there, 2 terms, 2 monomial terms in the polynomial. Our first monomial term, we have both x and y, so we want to sum or add those up. So the degree of the first monomial is 8, the degree of the second one's 4. What's the degree? We always go with the biggest one. This one would be degree 8. Okay, let's try another one. On the second one, anytime you see a variable and there's no exponent, we know those are 1. So this first monomial term, if we add these together, is degree 6. If we add these ones together, this would be degree 7 on the second monomial. If we add these on the last one, it's 2, which is our biggest one, 7. So this one would be degree 7. So degree tells you what's the biggest exponent on any single term. All right, we're also going to look at some operations today with polynomials. When you add polynomials, do addition, you basically just add like terms together. So if you're adding two or three polynomials, there could be any amount, you always want to combine like terms. Subtraction. When we do subtraction problems, we first want to add the opposite and then combine like terms like we do with addition. So basically we're entering the subtraction problem into addition problem, then combine like terms. And you'll see what we talk about when we do some examples here in a second. Finally, multiplication. Multiplication of polynomials, you want to distribute, then combine like terms. Distribute, and then combine like terms. So those are what we want to do. Those are what you do with the operations of polynomials. Let's try some examples. On number 3, this one we can see is a subtraction problem. When you are subtracting, what we said to do was add the opposite. So this second term, every single monomial term is being subtracted here. You can see our subtraction sign located right there. So everything's got to get subtracted. So basically what we want to do is turn this into an adding problem. We want to add the opposite. So we want to take this, turn it into a plus. But by doing that, that means we need to distribute that negative sign to everything. So everything's going to get the opposite sign. So this is going to turn to negative. This is going to turn to negative. This last one's already negative. That's going to turn into plus. So what we end up with is 3x squared minus 2x plus 3 minus x squared minus 4x plus 2. Now we combine like terms. So these two x squared terms we're going to add. 3x squared plus negative x squared is 2x squared. These two are like terms, so we're going to add those, negative 6x. And finally, our two constant terms, 3 and 2, add those, you get 5. And that's the addition. So subtraction, you want to change it to addition by adding the opposite. All right, let's try another one. Number 4, this one you can see is a adding one. So when it's adding, you just want to kind of almost pretend like those parentheses aren't there. You just want to add up any like terms. So what's our like terms? Well, we got a couple x squared terms. Add those, you get 2x squared. Add the x terms, you get minus 3x. Add the constant terms, you get negative 2. So adding, you just combine any like terms. All right, 5 and 6 are some more subtraction adding problems. I want you to try those before class tomorrow, see what you get on those problems. Why don't you flip to the back? We're going to try some multiplication ones. All right, multiplication. We said with multiplication you want to distribute. So on number 7, that's what we're going to do. Distribute this first term right here. So distributing, you got to multiply to each thing. When you multiply, exponent, if you recall from properties of exponents get bigger. So our first one here, 2 times 7 is 14. We got x to the first out here, x squared. If you add those exponents, you get x cubed. Minus. Now we multiply to the next one. 2 times 3 is 6. X times x is going to be x squared. And that's the second one. Now finally multiply to the last one. 2 times 5 is 10x. And so that's the solution to that one. Okay, I want you to try number 8. Let's look at number 9. This one's a little bit harder. And number 9, now we got multiple terms. If you got multiple terms that you're distributing, you just got to make sure again to multiply to everything. So our first term of n squared, we got to multiply here. n here. So if you do that, you got n squared times n is going to be n cubed. N squared times 4 is 4n squared. Okay, now we're going to distribute the middle term to both. So we're multiplying 6n here and here. So you're going to get 6n squared plus 24n. Finally, you're going to multiply that last one, negative 2 times n and negative 2 times 4, negative 2n minus 8. Finally, combine like terms and you'll get the answer. N cubed plus 10n squared minus 22n minus 8. We'll continue in class, so try those ones I set out, and we'll see you then.